Okay, we are in motion now, and I want to recap Newton's first law. Just specifically, I'm going to quote, I don't know if that's the right thing to do here. Let's just paraphrase: what is in motion stays in motion. That's all we're going to talk about. We're not going to do the other part, so we're just focused on this. What is in motion stays in motion. Just one part of that Newton's first law. Now, inertia is the resistance to change in motion. Okay. Or the thing doesn't want to stop. We'll explain. Velocity, what we remember is a vector, and it has direction, and it has speed. Okay. We're going to combine this stuff, kind of condense it too, so I have some space, and we're going to make this even smaller. That's really small. That's okay. Let's go here. So we're going to talk about primarily inertia. Now, inertia takes Newton's first law. We talked about it in Newton's first law video, which I actually kind of mixed inertia into it on accident. But anyway, and it blends it in and it uses velocity. Why does it use velocity? Because something that has inertia in a specific direction needs to have a specific direction for that speed. And I'm going to use fear and some sports in order to make sense of this. So think about it like this. Actually, let's use a train. That's quite fear inducing if you're in front of a train. Now, let's say there's a person here, okay, and this person is really confident that this mosquito here that's flying at this person's face, this mosquito has inertia. It's moving. Here's a western bound, east, south, north, a compass, right? So it's moving, and we won't do math in this. We'll just keep this conceptual. It's moving west, and this guy is holding ground just in a stationary position. Okay. So this bug's moving west, and this person's confident that if this bug hits the person, this person's going to be like, that's fine. Okay. Because the bug doesn't have enough inertia to affect the mass of this person. Let's just say the mass of this person is a lot, and the mass of this bug is tiny. Okay? We don't need to use numbers for this. All right. Well, now let's put a train. And I completely forgot what a train looks like. I think it's like that. And then I don't know. I forgot how many wheels are on each. I don't know. It doesn't matter. So a train, and the tracks appear, and it's heading straight for the man. Well, I don't know why he's happy now. Okay, now he's scared, and he's wearing glasses. Okay. So this train is heading for the man, and the mass of this train is immense. I don't even know how to read that. Immense. A lot. Way more than a lot. And this person's panicking. And his arms are now above his head. Okay? Let's just say it's moving west. It doesn't even really matter what speed the train is moving. Even if the train is moving incrementally, you don't want to be in front of a train, okay? Because the inertia that train holds just to move that much mass, even if it's just one cart, is a lot of energy to move that mass, okay? So this train is going ahead, and it could be going at 1 meter per second. I said I wouldn't use numbers, but who cares? 1 meter per second, 10 meters per second, and so on. That's bad, okay? Because the train, you ain't gonna stop that train. All right, that train's just gonna run you over. The fly didn't matter, okay? So we have the vector here of direction and speed. So it's going west, and we'll just say at a slight speed. Fine. So just to reduce how much math we're doing here. Okay, tiny, same thing, slight speed. Now, let's keep this guy super shocked where his eyeballs are coming out of his head for this next one. Now let's take this, uh, bug mass. We'll see if I can even make this a little more extreme. Okay. And we can make this ridiculous, right? We're going to make this a little ridiculous here. This is really ridiculous. Okay. Look at how nuts this is. I mean, seriously. Look how crazy that is. Okay. Imagine that. A bunch of tiny, slight moving bugs coming at you. Okay. Yeah, the inertia of one is not enough to, knock you over. But the inertia of many will cause a change. Okay. So there's a way to think about this that, you're basically loading up mass. These things have mass, and they don't want that mass, that compilation of many bugs is kind of like having one giant mass, because they're all through time. And what we've learned with velocity, or even acceleration, and I won't use numbers here, but VF minus VI over T, and velocity is change in displacement over time. Well, if you have a bunch of things that are hitting you, that are constantly hitting you over a short period of time, well, that's going to change your inertia to stay upright. Okay, you're going to easily get swooped off your feet on either of these occasions. So inertia, the way to think about it is, what would you rather? I like playing what would you rather games with physics. What would you rather confront? A moving train, or a singular bug, or a billion bugs? What would you rather if you had to? And that's how you can kind of conceptualize inertia. Which way is it moving? Is it going to hit you? Well, how would you fare with that? I hope you learned something about inertia today, and I hope you have a great day.